Hello, everybody. Can you believe it? Here we are, 4.1. Chapter 4 is about linear relations, which typically show a relationship between two variables, and these relations can be shown as a line on a graph. So for the first part, we're going to be looking at writing equations to describe these patterns. So first, a glossary term, table of values. You might remember this from grade 8 math. So often shown, say, like this, where you would have values of x and those related values of y. So say when x is 1, y might be 4. When x is 2, y would be 6. X is 3, y would be 8, and 4 and 10. And you could plot these on a graph if you wanted to. This is our x-axis and this is our y. And you would see that it ends up making a line. Now I'm just graphing an entire line here, something like this that would go on forever. Yeah, so you can use these table of values as well to make an equation. So let's do that. Notes, often objects or items in nature are related to each other. So for example, the number of plots on a farm is related to the number of boards used in creating a fence around its perimeter. So as well as a board between each plot. So you have, as you have it around, you would also have them in between the plots. So this first one, if we have one plot, we can count the boards around it. 1, 2, 3, 4. So for 1, we would have 4. For 2 plots, let's count the boards. We would have 1, 2, 3, 4, 5, 6, 7. So for 2 plots, we would have 7 boards. For 3 plots, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a 0. For 4 plots, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we can put these two sets of numbers into a table of values, and we can start to see the pattern based on these two things. So we can create a table of values that describes the relation between the number of plots and the number of boards used. So for 1, there was 4, if you recall. For 2, there was 7. For 3 plots, there was 10 boards used. And for 4 plots, there was 13. So you can look and see as we go up by 1 here, plus 1, plus 1, plus 1, we go up by 3 here, plus 3, plus 3, plus 3. So let's scroll down. Let's make a kind of prediction based on this, and then we're going to check our prediction and see if we were correct and if we need to adjust it. So in order to determine, in order to determine if an equation that best describes, there we go, this pattern, we must take note as to what is happening to the number of boards as the number of plots increases. So we notice that as n increases by 1, b increases by 3. That was the little plus 1s I put on the side of our, and the plus 3s I put on the other side of our table of values. From this, we might think that b is 3 times n, 3 times as much as n, as we would create the equation b equals n times 3. So we might think that it means boards equals 3 times the number of plots. Okay, that seems reasonable. For this going up by 1, this goes up by 3. Let's test out the idea that the number of boards is 3 times the number of plots. So let's do an experiment. Let's see if the equation works. In our table, when b equaled 4, we noticed that n equaled 1. So when there was 4 boards, the number of plots was n. However, when we plug 1 into our equation, b equals 3, which is less than b is supposed to be. So what they're saying right here, and what I maybe should have showed you instead of typing it out, is that if we substitute these numbers into our equation, so let's do that. If we would say 4 equals 3 times 1. And that's not true. 4 does not equal 3. So our first guess is not a very good guess. So because the equation is incorrect, we must alter it. So since our equation, here we are right here, since our equation was 1 less than it was supposed to be, let's try adding 1 to the equation. So we're taking our original 1 right here, b equals 3n, and we're adding 1. So because remember we got 4 equals 3, it would need to be 1 more. So let's try this and see if that works. And we'll test our new equation. So we can use any set of values. Remember, they were 1, 2, 3, 4, and the values were 4, 7, 10, and 13. So we can try the first one. Let's try, does 4 equal 3n plus 1? Yes, 4 does equal 3 plus 1. So 4 does equal 4. That's right. We can try another one just in case. So B, remember, is the number of boards. So let's try 7 equals n is the number of plots. So 3, 2 plus 1. 7 equals 3 times 2. That's 6 plus 1. And yeah, indeed, 7 does equal 6 plus 1, or 7. So this is a correct formula now. So the questions are, have you looking at some sets of data, making equations, and also about solving equations based on inputting information. So I'll be here to help. I'll tell you what questions I'd like you to do. Thank you so much.